Okay, good morning, guys. Today we're going to be studying triangle similarity. Back in chapter 4, we studied triangle congruency. This time we're going to study triangle similarity. Remember that similar triangles, that means they have the same shape, different size. The same shape, different size. So you will be able to use the angle similarity theorem, use the side similarity theorem, use the side similarity theorem just to prove triangles that are similar. Okay, so let's get ready, copy that down, and let us begin. Okay, let's take a look at these two triangles, triangles ACT and triangles ODG. Are they similar? Well, given information is that angle C is congruent to angle D. So I could mark that on the picture, right? Angle C, right here, is congruent to angle D, right here. And then they give us that angle A is congruent to angle O, right here. Now, remember, let's assume that this is 100 degrees and that this is 30 degrees. Well, if they're congruent, that means this is also 100 degrees and this is also 30 degrees. I do not need to prove the next angle to be congruent because by default, remember that the sum of the interior angles of a triangle must add up to 180. So if this is 100 and this is 30, by default, that third angle must be 50 degrees so that it will complete the 180. So all I need to prove is that two angles of one triangle is congruent to two angles of another triangle. I have already proven that the two triangles are similar. Remember how when we were trying to prove triangle congruency, angle did not prove congruency? They do not. However, for similarity, angle actually proves triangles to be similar. So remember, to be similar, that means they have the same shape and different size. They have different size. So they could be different sizes. As long as they have the same shape, they are similar triangles. So here is our first theorem. So make sure you copy that down, the angle similarity theorem. That if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar triangles, okay? So if angle C is congruent to angle D and angle A is congruent to angle O, then you can say that triangle ACT is similar to triangle ODG by the angle similarity theorem. All right? That is that. Make sure you copy that down. Take a few minutes, pause it if you need to, and let's continue. Okay, here is the second similarity theorem, which is the side angle side. If an angle of one triangle is congruent to an angle of a second triangle and the sides that include the two angles are proportional, they don't need to be congruent, they only need to be proportional, then the triangles are similar triangles. In this case, you have angle O right over here, right here, is congruent to angle A. And then you have that BO is to MA as OY right over here is to AN. If they are equal, that means those two ratios are equal, that means they are proportional, then you have triangle BOY similar to triangle MAN. Already, let's look at the example. Let's say triangle BOY right here and triangle MAN, given that angle B is congruent to angle M. So given angle B right here is congruent to angle M. Notice these two are included, or the angle is included between these two sides. Well, this side right here corresponds to this side. So 4 is to 8 as this side right here corresponds to that one. 3 is to 6. Notice this is 1/2 is equal, if I simplify that one, is also 1/2. So 1/2 is equal 1/2, therefore they are proportional. Therefore, by side angle side, these two triangles are similar. Then I could say that triangle BOY is similar to triangle MAN. Boy and man, they're similar, see? That's basically our second similarity theorem. And this is our third and last similarity theorem, is the side, side, side. As long as I can prove that all corresponding sides are proportional, then the triangles are similar triangles. In this case, if EA is to LO, as AR is to OB, as RE right over here is to BL, then, and those are equal ratios, then triangle ARE is similar to triangle OBL. Okay, here is the example. Now I'm looking for sides that are corresponding to each other, so I know this short side corresponds to this short side right here. I know that the longest side, which is this one, corresponds to the longest side on this triangle, and therefore the last side, which is the middle, corresponds to this one right over here. Okay, so now I could go ahead and set my proportions. So 15 is to 5, as 39 is to 13, as 36 is to 12. And I check those proportions and see if the ratios are equal to each other. Well, 15 divided by 5 is 3. 39 divided by 13 is 3. 36 divided by 12 is also 3. Notice the ratios are all the same. Therefore, the two triangles are similar to each other. Okay, what you will be working on the exercises, just to give you examples, is right here. Let's go to the exercise examples. Determine if the following triangles are similar. If so, state the reason why. Remember, we can only prove triangles similar by angle, angle, side, angle, side, where the two sides are proportional and the included angle is congruent, or by side, 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 where all three sides are proportional. Well, the first thing I want to do is always identify what are my corresponding sides. So I know that this side right here corresponds to this side right over here in this triangle. Then you have this side, WN, corresponds to WU right over here. What else do I know? Well, I know that these two angles are vertical angles, or these two angles right here are congruent by default. So I just need to find if these two sides are proportional. So if 50 is to 15, as 60 is to 18. So let's try that and let's figure that out. Let's see. Is 50 to 15 as 60 is to 18? Well, I could go to my calculator and I'm going to punch that in. 50 divided by 15, it gives me that is 10/3, and 60 divided by 18, it also gives me that is 10/3. So that means the ratios are equal to each other, therefore they are proportional. So then I just have to write my similarity statement. My similarity statement, remember to write that triangle right here, the symbol first. Don't just write the 3 points. Make sure you have this symbol. So triangle WB, V corresponds to M, W to W, so it will be W, M, and then N. Okay, so those are, and by what? If so, state the reason why. Well, it would be by side, angle, side, right there. Side, angle, side. Let's take a look at this second one. This second one, it would be by side, side, side if they are proportional. So the first thing I want to identify is my corresponding part. So I look for the shortest side. Shortest side here is 8, right? EC. Which one is the shortest side here? Well, it would be JL. So that is there. And then I go for my middle side. Middle side would be 9. And notice this one is not 60, but 59. So do be careful when you are working with these. Make sure you go in by the measurements. And then last but not least is the longest side, which is 10 right over here, which happens to be 60. Now that I have everything identified, now I can go ahead and check. So 8 is to 48. See, green to green, 8 is to 48. As 9 is to 59. As 10 is to 60. Well, this is 1/6 right here, and I'm pretty sure that that's not 1/6. So, but let's test it. 10 is to 60. That's 1/6. Oop, I put 11, so let me delete that. 10 is to 60. That's 1/6. Then 8 is to 48. 8 is to 48. Enter. That's still 1/6. See, 1/6, 1/6. Now take a look at that one. 9 is to 59. 9 is to 59. Is that 1/6? The answer is no. I have two that are proportional that I must check all three if I'm going to do by side, side, side. In this case, they are not similar because one of them is not 1/6. This is 1/6. This one right here is 1/6, but that one right there, it is not. Therefore, these two triangles are not similar. Okay, these are not similar. So that's what you would write. There is no similarity statement because they are not similar. The third example, I want to check. The two triangles that I'm checking is, just to show you, is this big triangle right here. And then I'm checking this small triangle right here because they are similar if these two lines are parallel. If these two lines right here are parallel, then these two triangles are similar, okay? So that's what I am checking. So what do I know? Well, I know that this side would correspond to that side right there. That this side right here in the small triangle will correspond to the long side of the big triangle, which would be from here to here. And then I know that this side in the small triangle would correspond from here to the long side. Well, the long side goes from here to here. And I'm just going to add these two numbers. And I'm going to say, well, this is 36 plus 81. 6 plus 1 is 7. 3 plus 8 is 11. That's 117. Okay? So now I must check it. So, is 24 to 78 as 36 is to 117 as 32 is to 104? If that is the case, then if all these ratios are equal, then that means these two triangles would be similar. Well, let's check. Was 24 to 78. That's 4/13. Then we have 36 to 117. That is still 4/13. And last would be 32 to 104. That's still 4/13. Therefore, yes, they are similar by side proportionality, right? So this is triangle. Remember to put that triangle. Q corresponds to Q. R to D. And S to C. And there you are. Triangle QRS is similar to triangle QDC. Last one is easy because it's telling you that this angle right here is 89 degrees. So this is congruent to this angle, which is also 89 degrees. And then I know by default that these two angles right here are vertical angles. Vertical angles always congruent All I need is two angles, so therefore I could say yes, they are similar. I don't need to test proportionality by angle. Okay, and this is triangle LM. So LM, so it will be LEF. LF. And there you have it. Okay, so now what you have to do is you have to do your practice exercises and then your delta math. So let's go to work, guys.